And that extraction of information is what's really key to the value that the Internet of Things provides. And we'll find ways, I'll talk more about, of how we transform industries and the way that we work and the way that we live by gaining more access to information, things we couldn't see previously. So we thought with that kind of backdrop, we'd take a moment and kind of imagine what's possible. I want to share a video with you. So it's kind of fun to imagine what's possible with some of those examples. I've also often talked to people who say, well, okay, so that's all interesting, but why do we care about the Internet of Things? You know, what's this all about? Well, we have to care about the Internet of Things because Gartner just updated their hype cycle in August for 2014, and the Internet of Things is at the very peak of the hype cycle, right? So we have to care. It's the most hyped thing there is today. And of course, we all know that whatever hits the peak of the hype cycle is going to be a resounding success, right? We know that as well. But while it may be hyped, I have to say it's really hard to ignore the numbers. And I'm going to share some of those with you in a moment. But I also want to talk a little bit about some real deployments, as I said earlier, some things that are really beginning to happen. And we're going to show you a very compelling example a little bit later. So as we talk to analysts, you know, the analysts are throwing out different numbers. Some are saying, you know, 200 billion devices. Some are saying 50, 20. You know, we look at it and we say 50 billion devices seems to track pretty well with the data that we've been looking at over the past 7 or 8 years. And if you think about 50 billion devices, that's a huge number. But what's essential to those kinds of numbers is those devices have to become connected. And what's really important here is that pervasiveness of connectivity to be able to connect those devices, right? And what we're seeing from a recent Goldman Sachs study, it said that the cost of connectivity has dropped about 40x in the last 10 years. 40x in the last 10 years. Now, as we connect all those devices, they're going to be generating data. That's the whole reason we're connecting them. About 35 zettabytes of data by the year 2020. 10 to the power of 21. I had to go look it up. And then finally, that data has to be stored and analyzed, and that analysis takes computing capability. And thanks to Moore's law, the cost to process and analyze all that data has decreased about 60x in the last 10 years. So 60 times lower cost to do that level of computing that's necessary. But what's also important here is to look at the devices as only one piece of the puzzle. The real value, and I'll say the real promise of the Internet of Things, is to be able to use the information they're generating to transform the way that we work and the way that we live. And we're seeing that will translate into new products and services, in some cases greater productivity, greater efficiency, and from a business perspective, we all say, hey, that's better margins as well. But one of my favorite big numbers, and I use this frequently, is a number that John Chambers has talked about. The Internet of Things will generate $19 trillion of economic value by the year 2020. That's a huge number, right? And if we look at what's really been transpiring and heading in that direction, is a report that the McKinsey Global Institute just published that said the number of connected machines has grown by about 300% over the past 5 years. And that's really due to the value that companies are beginning to see as they connect these kinds of things. So as we then contemplate the kinds of challenges that we face and the things that we need to be mindful of, it begins with trust. Inbar mentioned that earlier, is more and more devices become connected. The companies trying to deploy these systems are dealing with fragmentation, interoperability issues, and certainly security challenges. We're going to have different devices from different companies that we want to be able to interconnect, and we want to be able to trust what they're telling us. It seems like every month I'm reading another news article, I'm sure you are as well, about a security breach, about more credit card information that's been pulled out of some system because some subtle, innocuous weakness in that overall system. And I think that's one of the challenges as we connect 50 billion devices. We need to ensure that we can trust what those devices are telling us. There was a comment in that summary about insight and impact, right? And so this is one of those things that I think is compelling. As we formed the Internet of Things group at Intel about a year ago, I spent some time out on the road meeting with customers. I had the opportunity to talk to the CIO of a large fast food chain. And the CIO was telling me that they had been working with the industry over several years to get fryers and refrigerators and freezers and all those kinds of equipment that sit in the back of the restaurant to be able to connect, to be able to provide data. And he said, he's very pleased that the industry had responded, and the equipment that was being put in those restaurants have the ability to connect, and they're generating data. But his comment was really funny. He said, I know they're generating data and they're communicating that data, but they must be communicating with extraterrestrials because they're not communicating with our data center. And so this was the challenge that he was facing, is how do we now connect those devices and begin to get the value? So to be able to have trusted devices that provide an insight, but then also have business impact in the end. So I think this challenge of connectivity is something that we as an industry have the capability to fix. We have the tenacity to go fix, and I think that's one of the challenges that we face as we go forward. So as we think about how to solve that problem, how do we begin to approach it? Well, of course, it starts, as I said, we need to know these devices are secure. And we need to be able to connect them, right? We need to be able to have the ability through many different protocols and means to get them connected, wired, wireless, various different kinds of technologies. We need to manage them, right? And I'll talk a little bit more about this, but when we talk about the number of endpoints that we're going to create, we've got to be able to manage them over time, and then we, of course, want to be able to analyze the data and gain insights from what we're learning as we go forward. So Intel has defined a reference model that describes how endpoint devices connect to the data center or cloud. And we've described the model through some five basic tenets that really outline what's necessary. And of course, it starts with security at the bottom, as I indicated earlier, and that's both hardware, things that we build around the devices from a hardware standpoint, and the software that sits on top of them. And of course, next we've got to manage. As I said, with the number of devices we're talking about, we need to be able to discover them, provision them, have them up and running on our networks and feeding us data in a very straightforward manner. And then we need to make sure over time that we can continue to identify those devices, make sure they're up to date, make sure they're current. And then with all the different types of devices that we're talking about, data normalization is incredibly important, right? We need all these different types of endpoint devices, as I mentioned earlier, to be able to speak the same language, or they need to be able to have an interpreter to help them communicate with each other. And then, of course, as I said, we need to have the ability to extract information from all that data, and the term we use here is actionable analytics, the ability to draw conclusions from that information and change the way that we do things. But last, and probably most importantly for all of us, at least, is we need to create the capability as this infrastructure builds out and developers are creating solutions, that there's a way to be able to monetize those solutions as well. I really believe we're on the cusp of a new wave of innovation. It's going to change businesses, and the ability to extract the value from that is so important. The other thing that is critical to think about here is that the complexity of what we're trying to implement across all these different market segments and industries, across all the different solutions, legacy equipment and new equipment, is the partnerships are essential. I don't see that any company is going to be able to do this alone. We need the partnerships to be able to help customers implement solutions. From an Intel perspective, we're very proud of the partnership that we have with Cisco, and I'm going to talk a little bit more about that later. We've been one of 5 companies that has helped create and found the Industrial Internet Consortium. So GE, Cisco, IBM, AT&T, and Intel. And this is an important organization in terms of defining what's necessary to enable these systems to be deployed and to be able to feed those requirements into standards bodies so that we evolve standards as necessary, but also to charter work groups to go out and validate and optimize and make sure that these systems work together. Similarly, the Open Interconnect Consortium describes a single connectivity framework to enable device-to-device interconnections and that interoperability I talked about earlier, but to do so in an open, unencumbered manner. Intel, Samsung, Cisco, and MediaTek have founded this consortium, and it continues to grow very quickly. We have over 75 companies involved, signed up, members of the Industrial Internet Consortium, and over 30 companies that are signed up today as part of the Open Interconnect Consortium. So 2 important bodies moving very quickly to help create the capabilities. But finally, scale is really important as we go forward as well. As we're talking about the kinds of numbers that I described earlier, driving that level of scale is important. And from an Intel perspective, we have a long-standing ecosystem of companies that we've worked with, technology suppliers in embedded industries, many of the industries we're talking about, as well as extensive experience, obviously, in the computing and server space to help drive scale and deliver the kind of capabilities for the kind of numbers that we're talking about. And we think that we can work together with partners to continue to deliver those kinds of repeatable solutions. So as I noted, the Internet of Things requires technological solutions to deliver on the capabilities. And from an Intel perspective, we've been delivering processors for embedded applications for over 30 years. We've been working closely in partnership with Cisco for over a decade. Now, the processors that we deliver are used in endpoint devices, but also in gateways to be able to connect those devices, to be able to provide that legacy interface, to be able to translate protocols. And we've extended the breadth of our computing from our high-end Xeon processors to our small footprint, low-power Quark processors. And some of these processors are used increasingly in the network infrastructure to provide greater scalability, more cost effectiveness, to continue to drive down the cost of connecting all these different devices. And of course, we provide a wide range of processors and technologies around servers and storage processors, big data analytics tools, non-volatile memories, networking to enable the data center to also scale and give us that capability for doing analytics. But at the same time, we use these technologies to help support the kinds of solutions that Cisco is building as an example. We're delivering really high-performance 64-bit computing with integrated virtualization technologies, integrated security. And this allows Cisco to take advantage of the multiple multi-threaded cores to build headroom into the equipment that they're delivering and be able to support the kinds of computing that will happen throughout the network infrastructure. We provide OS support, things like VxWorks from Wind River that provides for real-time applications at network speed. And we're delivering technologies around network function virtualization as well as software-defined network. So as I said, Cisco uses many of these technologies for that underlying infrastructure that I'm talking about in their multi-service edge, core, and data center solutions, and they deliver ruggedized products like their routers, EPC, switches, security appliances, and also products like the non-rugged ISR, the core networking, and again, server data center type of solutions. So the collection of these technologies really provides that underlying infrastructure where Cisco delivers significant value that's essential to create that kind of computing capability that's necessary to deliver on fog computing. And I think we'll see the capability of developing economic solutions to sort out where that analytic processing takes place. Does it take place in something like a gateway or within the network infrastructure? And we'll see those decisions move over time as we learn through big data analytics, and we can move more and more of those applications into the fog or towards the edge of the network. So, I told you at the beginning that I would talk about some real examples, things that are happening here and now. And I wanted to start with one that's actually within Intel. Within our Penang, Malaysia assembly test facility, our employees got really excited about all the things happening around the Internet of Things and understanding the value that it could deliver. They worked together with Mitsubishi to connect a gateway to a particular tester type that we have in the factory. This tester's used to test our microprocessors. And believe me, when I've gone to those factories are incredibly connected. We gather all kinds of data. But they wanted to gather more data about the underlying workings of these tools. And what they found was they could almost immediately begin to identify elements of the machine that were nearing failure and to schedule the replacement of those parts as part of the standard preventive maintenance, saving energy. And what they found through this is that one tool type is delivering about $9 million a year of savings just by having access to this kind of information. The second one is a company you might recognize. They have big 18-wheel trucks running up and down the highways in the United States. It's called Saia Trucking. Saia uses a system from a company called Vnomics. Vnomics builds a terminal that goes inside the cab of the truck. It's a gateway. It's collecting data from about 50 different sensors in the truck and aggregating that data together. It's feeding it back into the data center. And in the data center, it's looking at the route the truck is taking and the performance of the driver, how he or she is doing in driving this route. And it provides real-time coaching. Hey, instead of going over that hill, you might want to take a detour and go around the hill. It'll save fuel. You shouldn't take off quite as fast from the stop sign. And providing that coaching so the driver can be even more efficient. Well, Saia has said as a result of deploying the system, by the way, when I asked them, how many trucks do you actually have this in? They said proudly 100% of their fleet has deployed this system. And it's delivering about 6% fuel savings to them over an annual basis. And I said, well, 6%, that's a nice number. 6% is $15 million a year for them in saved fuel costs. And we said, you know what, if we could be bold and think about applying that to every truck running up and down the roads in the United States, it would save about 38 million tons of CO2 being spewed into the air. The third example I want to share with you is a building management example. Intel, Cisco, and a company called Rudin Management have integrated a system called DBOS that Rudin builds into a building to be able to look at ways to better manage that building and to drive energy savings as well. And what they found after installing the system is over about a year's period of time, they've saved about $1 million in energy costs to manage that building. I thought that was a pretty amazing number. But in the conversations that we've had subsequent to that, you translate that across just the city of New York. It has the potential to deliver about 50 cents per square foot across the entire city in energy savings. Now, this is such a cool example. I wanted us to take an even closer look at this one. And I'd like to bring a couple guests on stage to help me out with this. I'd like to introduce Cisco's Vice President of Energy Management Solutions, Dave Goddard, up on stage, as well as John Gilbert, who's the Chief Operating Officer of Rudin Management. And they're going to come up and tell us a little bit more of this compelling story. John, thanks for joining me. Hey, Dave.
Hey, Doug. It's great to be here. Thanks for having us.
So, Dave, maybe let's start with you, and just tell me a little bit more about the energy management solution, what Cisco's doing in that space.
Yeah, so absolutely, Doug, I will. So energy management, especially in commercial buildings, is actually not a new conversation. In fact, the majority of the sponsors and representatives here have been doing the management of the core infrastructure of buildings exceptionally well for a very long time. So what role then can Cisco play in energy management? Well, it actually turns out that there's a very, very significant class of assets out there which historically haven't been managed particularly well. And those assets are the IT assets. And as we've been discussing over the last few days, those assets themselves are burgeoning in this environment. Depending on the type of company, if you have a large number of knowledge workers in carpeted office space, if you have large data centers, if you have a lot of infrastructure and labs, that can be anywhere between 20% and up to 80% of a building's energy consumption can come from the IT assets. And of course, all of those assets are directly attached to the network. So what Cisco's doing is reaching into those assets, providing control of those assets, and then offering those assets to the building control paradigm so that we can incorporate more agile and flexible capabilities into building control.
Great. And so Intel and Cisco have been working together on this example. Maybe you can share a little bit about what we've been able to do together here.
By all means, and in fact, to answer that question, I'm going to ask you to come over here, and I'm also going to introduce onto stage Chad Sleeman, who's an expert in my business unit. Chad? So we were, let me keep talking while Chad joins us.
Thanks, David.
We're going to do a little demo. Apparently demos rarely go wrong, so we thought we'd risk it. If you could jump to the other slide, or have we lost the slides?
Nope.
Okay, so I just talked a little bit about the IT assets and bringing IT assets alongside the building infrastructure into that control paradigm. But what we're seeing now is more and more creative approaches to addressing energy management within a building. And we'll talk a little bit more about that in some detail. But Chad, as an example, if you could just highlight the assets that we've got on the desk here.
Absolutely, my pleasure, David. So you talked about the traditional IT assets, right? So we have your OS-based devices, which is your typical Microsoft, Mac OS, Linux, Sun OS, servers, desktops, your IP phones, right? Non-OS devices, your printers, copiers, fax machines, wireless LAN access points, right? But let's not forget the non-traditional IT devices that historically have not been connected, right? So let's talk about lines that can be used for daylight harvesting. Let's talk about vending machine, ATM machines, coffee makers, water coolers, right? So now we're able to discover all those devices. We're able to gather pertinent information about those devices, such as the behavior, the status that it's in, power consumption.
If I could comment on that, Chad, just quickly. So we've talked about the IT assets and the building assets, but to be able to reach those non-traditional assets that we're now bringing in, daylight harvesting, enabling you to manage the ambient temperature in a room using less heat or less cooling as necessary, we need gateways. We need access through things like the Intel Moon Island Gateway to be able to reach those devices and now bring them as a third subset of assets that you can manage in the control paradigm.
Fantastic. And so we're in this example, we've been working together with Rudin. And so, John, I thought maybe you could take a moment, tell us a little bit about Rudin Management. What do you do? Tell us about the company.
Sure. Rudin has owned property in the city of New York for over 100 years. If any of you are coming to New York in a couple weeks to run the New York City Marathon, you win, you will hoist the Samuel Rudin Trophy over your head.
I'm certainly going to give that a try, by the way.
If you don't win, it sits in our offices 11 months out of the year, and you can come and hug the trophy. It's about as close as I ever got to it. If you're in the intelligent building space, we did 55 Broad Street. We own that building. That's been by many called the grandfather of all smart buildings. 32 Avenue Americas is an internet building that about a third of all internet traffic in the world comes through that building. And 130 West 12th Street, which is a pre-war project that we just completed, renovation, and you can control all of your lighting, all of your HVAC literally off your iPad or your iPhone. So we're a real estate company that used to dabble in technology, and we're now a technology company that dabbles in real estate.
Great. So you created this application called DBOS to give you greater insight into how you manage those properties, incorporating some capabilities that then marry to what we were talking about earlier, the technologies from Intel and Cisco. Maybe tell us a little bit about how that came about, how you created DBOS,
Sure.
and how that all works.
And maybe we can just go to a live, we're going to do a live, you're going to see how it works. DBOS stands for Digital Building Operating System. We were asked by Con Edison in 2007 to be the commercial office petri dish for their smart grid demonstration project. And what we immediately saw was that in order to grab data from the grid, we needed an operating system. We didn't have that catcher's mitt. Not only didn't we have the catcher's mitt, but we couldn't throw the ball to the base that we needed to throw it to. We didn't have that actionable intelligence that Doug was talking about. So we created DBOS. And DBOS is, first and foremost, it integrates all the different systems within the building so that chillers can talk to turnstiles, can talk to fans. If you go to the slide, it uses machine learning algorithms. As we look at the chart that you're looking at right now, the red line, every day, DBOS creates a prescriptive and predictive path for that building. And the building operator, as you see on the blue line, that is the actual path that the building is taking. It's in real time right now. So as you can see, operators done a pretty darn good job of operating and maintaining a level of savings and efficiency based upon that predictive and prescriptive algorithm. You can also see the two vertical lines on the graph. First is in the morning, it tells the operator what's the optimal time to start that building up. And in the afternoon, it tells the operator the optimal time to when that building should be ramped down. You should also notice in the middle, this is not your typical curve because it has that little dip in the middle of the day. And what we learned is that occupancy plays such a huge role in ultimately delivering comfort to our customers. And what we do in the middle of the day now is we actually have a mini ramp down at lunch. So that at lunchtime, we literally modulate fan speed down. We save roughly 700 to 800 kilowatt hours per hour for 2 hours in the day. And then suddenly we realize the curve that we now have a double humped camel. We now have an opportunity to utilize batteries that never had a compelling economic model to basically shave that peak, the first camel's hump, turn the battery off, people go to lunch, shave that peak on the second camel's hump. Totally reshape that curve and ultimately get rid of all the demand charges that we pay. As you all know, we pay electricity on the highest price at the worst time. So the ability to do this is a huge opportunity ultimately to really grab hold of the building's brain, if you will, and to create that brain, give that building a brain, because the data is remembered. The data is learned from. So tomorrow, DBOS will have learned from what happened yesterday and the week before, and again, reshape that curve. So it's a wonderful opportunity that we found ultimately not only to take information from the grid, but to utilize the Cisco and Intel. We always had a heart, the building, the engine room. We now have a brain. Now what we need to build is the central nervous system. And at the core of that central nervous system is Intel's gateway, Cisco's EnergyWise.
So, John, I think you're also going to show us some of the impacts because this is very real, and we've seen some tremendous results. So,
yeah, I think the next graph that Chad's going to pull up is a really fascinating one. And what we're going to see is 3 floors at 345 Park. Can you pull that up? It's booting.
Oh, we need to jump back to Chad's screen. Sorry, guys.
Back to my laptop, please.
So what we're going to see is 3 floors. The top graph that you're going to see is a space that was built roughly 12 years ago. As you can see, the y-axis is kilowatt hours, x-axis is time. So we're literally looking at a week's worth of data. That top graph, if you notice, same tenant to the second graph. The peak of the second graph is equal to the base load of the first graph. In effect, all that energy use on that first graph is waste. So what EnergyWise does, and what you should also notice, is the base to peak load ratio that we're showing here on average is roughly 65 to 70%. Now, if you were like me last night, who woke up at 4:30 in the morning and peeked outside to see, what was going on, the entire city of Chicago was lit up. Nobody in those offices. What EnergyWise does, brilliant product, it's a digital kill switch. It basically programs, so you don't have to modify people's behavior, convince them to turn stuff off. It turns it off utilizing the EnergyWise matrix. And if the last graph is actually the route and management floor, 2 floor and a half, at 345 Park. Now, if you look at that base to peak load ratio, it's roughly 40%. Why? Because we instituted EnergyWise. So as we go to our customers, and as DBOS collects the data, expresses the data, remembers the data, learns ultimately from that data, we immediately share that data with our tenants. We show them how bad they are. They say, make us better. We turn to Cisco, EnergyWise, knock that base load down. So it's a wonderful partnership that we're really excited about, and that we're able to really take this forward and ultimately allow our customers. And remember, 60% of a building's energy is consumed by tenants. Only 40% is at the core: elevators, lighting, common areas. So DBOS is the first tool that we found that really attacks that 60% of the problem.
Hey, John, looks like the analytics from DBOS told my devices to go to sleep. It shut them off.
Well,
nobody noticed, right? So, but the phone is off, the laptop is off, lights and shades are down. So it's amazing.
Perfect example of ultimately how you can take that actionable response and effectuate energy savings in real time.
So I think a great example here of the Internet of Things and what it delivers. So John, Dave.
Well, Doug, before you end,
yes.
To me, what you're looking at right here, this is the Internet of Things.
Fantastic. So thank you. Thanks, guys. So, we then look at, kind of in summary, that the Internet of Things really comprehends every point in the system. I think that this example, the other examples I gave, talk about real value being delivered here and now. Now, as I said earlier, Intel defined a reference model that describes how these trusted devices can be connected to the data center or the cloud, how data can be ingested and analyzed, and how information can be extracted with data analytics technologies. And we firmly believe in the power of collaboration. Hopefully this was a great example of that. And how we can collaborate with the industry across not only these kinds of partnerships to deliver solutions, but across industry consortiums and standards bodies to deliver on capabilities. With our hardware and software solutions, we're providing those foundational capabilities for Cisco's fog computing. Essentially the end-to-end Internet of Things networking gear that's necessary to deliver on the kind of capabilities I've been describing. As I said at the beginning, it's really the Internet of Everything powered by Cisco with Intel inside. So let's all go out. Let's all collaborate on solutions. Let's find the kinds of capabilities, extract the information that will transform the way that we work and the way that we live. Thank you very much.
Ladies and gentlemen, please welcome Cisco's Chairman and CEO, John Chambers.
Good afternoon. What a difference a year makes. A year ago in Barcelona, there were 800 of us in this room, and to be very candid, it was the true believers of